Hello, welcome back to Math 110. Today's lesson 1.9, we're going to go over a few ways of doing some lists, build a bar chart, do a scatter plot, and then we're going to look at some statistics terms like population, data, samples, and some of these concepts that are related to that. So here's some prep skills, and skill one is just read data from a list. Unorganized data can be difficult to read, especially if there are a lot of values or many identical or similar values. In that case, rewriting the list in order is helpful. So here is a list of the scores for 20 students on a 30-point quiz are listed here. Here are their scores, 30-point max. And if just to look at this as it's all mixed up together, it's pretty hard to get a good comprehension of, how everybody did. If you order the list, so you put them in order from like these, the minimum to the max score, then you can scan along and kind of see how all the data lies. I've got a bunch of 4 perfect scores. There was a 12 was my lowest. Looks like we had a lot of 27s. So this is kind of the middle of the data. Most common scores are 27 and 30 they see, and the lowest score was 12, highest was 30. So the first thing we would like to do, if we've just got some data, just a bunch of numbers that we want to analyze, is to put them in this sorted order. Okay. A bar graph is used to compare this thing. You can put these things in terms of different scores. I'm going to look at that in just a second for something at what they would do here. But I would like to focus on this one and kind of go back and do that version of it. So they want us to take this data. This is the data below, the number of classes missed in one semester by all students in a 5-day school week. Here's the number of days missed. Arrange the list in order from smallest to largest. What number of days missed was most common? What was the least and most days missed by anyone in the class? And then draw a bar graph in these things that we're going to call bins 0 to 1, 2 to 4, 5 to 8, and then more than 8 days. So I'm going to break out of the slides for just a second. I'm going to take a look at this stuff in Excel. Okay. So I kind of built this for us. I put the numbers here, but what I wanted to do is I'm going to go back and clear this and show you some capabilities of Excel looking at data. So here are the numbers as they were given. They're all mixed up. I can't, I would have to go back through and by hand 0, 1, 2, 3. But Excel is excellent at doing this stuff for me. So basically, I'm going to keep the data like it is. Right-click, copy. I'll go back here right beside it. I'm just going to paste them by 1, 2, 3. That value. So these should be values anyway. But I'm going to get out of here. Now I'm going to select this data, and I'm going to let Excel sort it for me. So I do that by going to the data ribbon up here. Here's the data tab, here's my ribbon. And then this A to Z will sort. This basically is the sorting options here. So I want to go from sort smallest to largest, and it's going to say, there's other numbers here, do you want to include all of this stuff? And I just want to do the current selection. So there it sorts it for me. Here's the zeros. So if we went over here and looked at, there's the zeros. The biggest number should be 18. There's a 10 in there. But here's the sorting from smallest to largest. So here's the zeros, the 1, 2, 3, 4, 5, 6, 8, 10, 18. It looks like zeros were the most common. 1, 2, 3, 4, 5, 4 ones. I could actually go over here and do like I showed you before, count if 0, count if 1, count if 2, and it would actually give me the counts from each one, 0, 1, 2, 3, 4, 5, 6, all the way up. But we're going to work in bins this time. I need to, this got pulled over, so I'm going to insert like this. I'm going to, here's my bin, just let me do it this way. And clear And here's the frequency. Okay. So here's the bins that I want to put in. I just typed these out, made sure if I go back to the home that this is text only so that it recognizes this as text and not like some date that I'm trying to enter. You have to be careful with what form of the data that you're doing it in. But these are all text, more than 8. So with it being sorted, all I have to do is go. I could actually get Excel to do this through some count formulas. But I'm just going to go, this is small enough that I'll just do it by hand. 0 to 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. And I put the frequency of numbers in there. 2 to 4, since it's sorted, all I got to do is just start 2 to 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I continue on. 5 to 8 is only 3, and then above that 2. Okay. So now if I wanted to actually build that histogram chart that they're talking about, the bar chart, I go through here, do my recommended charts. That's what I'm looking for. And then if we wanted to make this a little nicer, I could go here and format the data series and then do some series overlap here, gap width. There's no overlap in here, so that should be good. Okay. So we can expand these out and still have, there's our full chart. Okay. We could format this and add some titles to our axis. Remember our axis, our x-axis, our y-axis. Okay. So I wanted to show you that. I'm going to X this out. In addition, later on, I'm going to go ahead and show you while we're in here, and then I'm going to go through. Sheet 2, I've got this time series. We're going to look at subscriptions later on. Here's the year, and then here's some newspaper subscription rates. And they talk about doing a scatter plot and then the time series. If I went here, let's put some labels in here. This is the year and subscription rates. Open this up a little bit. We could do some things like bold. Open it up a little bit. Okay. But I want to select these two. Everything. Excel is usually pretty good to recognize that these are just titles of the data. Recommended charts. There would be some things. I wanted to show you this one though that is just the scatter plot. This is the scatter plot with just the dots. Here would be just the points if these were my XY coordinates. 2001, height 55.6. Okay, so those would just be a scatter plot of just the dots. And then we can do things though. If I get rid of that, go back through recommended charts, and then do, maybe with the trend line here to show you this line just captures a little bit that these are going down, these subscription rates, and we'll talk about that in just a few more minutes. Okay, thought that would be helpful. So let's go back. Here's what we're going to be talking about over the next couple of slides. With the rise of online news sites and social media, many people have declared the death of traditional news sources in our country. But are newspapers really dead? Are they even sick? Statements like everyone just gets news online now, or who even reads a newspaper anymore, aren't evidence, they're opinions. In order to decide if they really have a significant decline in traditional news sources, we need to do better than listen to anecdotes or read opinions in 140 characters or less. So what we would like to do is go out and get evidence. And evidence we would like to gather is some form of data. Okay? This could mean a lot of different things, but they are basically measurements or just items of interest. These are measurements or observations that are gathered for an event under study, what we are concerned with. And what we're concerned about here is newspaper subscription rates. Are they truly going down? The term data age is coming to vogue to describe this era because of the vast amount of data that is available to anyone with internet access and a web browser. One of the fastest growing areas of employment is this area called big data. And it's taking all the data. If you consider Amazon purchases, they just do a huge number of purchases a day, taking all that data and then understanding things through statistics. What was the average purchase value? What was some information from the user? They've got their account set up, their age group, what do they usually spend their money on. So gathering information out of that data is a pretty big area of study. Okay, so let's go on through here. Let's take a look at this. So pull down here so I can read this. Let's slide me down. There are a number of different approaches we could take in trying to evaluate the condition of traditional newspapers, but all of them would begin with gathering relevant data. We could study things like circulation numbers, advertising revenues, how many people read print newspapers compared to online news, and many others. And a lot of that material is going to be, you'll understand that when you get into your majors or you spend some time working at your job. You'll get an idea of what would be the right thing that you want to extract. Okay. So in here, this table is showing, here's the year, and this is what I plotted out previously as that scatter plot. Here's the average circulation in thousands. Back in 2001, it's 55.6 thousand, and then 55.2, and it's continued to decline for 37.7. So if we did the time series or the scatter plot, what conclusions, just from the data from the table that's laid out, since it's nice in an ordered fashion, we could see that the average circulation seems to be declining over time. Table is good, it gives you the value. When we look at that time series as a chart, it's a good visual aid. I can see it very quickly. I don't have to focus on the numbers. I can see what it's doing. Here was the scatter plot. If we did it by hand, I'd go through, do a little grid. Here's my x-axis, my y-axis. I want to label it. Average circulation in thousands. Remember, we need a scale. That's our scale. And here's the year so that we know that each one of these is now 3s. Gives that by 2. Okay. So the graph reinforces that average circulation is declining. A graph picture is worth 1,000 words. It's really easy to see that something's declining there. The data that we've seen so far seem to indicate a clear negative trend for newspaper circulation. But where did that data come from? If this takes into account all print newspapers in the country, so if we could go and access all the companies that are doing print media, and we could get their subscription rates, we would know where it came from, and that certainly would be more compelling than if I got the numbers from a handful of, let's say, even major newspapers. Okay, so let's kind of think about some terminology here. A population, this consists of all the subjects under study. A sample is a representative subgroup or subset. So we don't really know from that previous data, did they go and talk to every newspaper / print outlet and see what their subscription rates were? Or did we just go and talk to a few of them, or did we get the data that we really don't know? If it's the full set, that's termed a sample. Okay. And hopefully a sample, if it is a good sample, to try to get some ideas. We use sampling to get ideas about the population, and we hope that the sample is a representative subgroup or subset of a population. If I went to one little small town rural newspaper, that would not be a representative subgroup of all newspapers. I mean, there's some major newspapers, Washington Post, New York Times, etc. Okay. So, in this case of the newspaper circulation numbers, the population would be all newspapers in America. Okay. So, in terms of what we're talking about, this is our area of interest, newspaper circulation numbers. The population of what we're concerned with are the newspapers in America. How about the world? That would be a different population and a different study altogether. But right now, we're only concerned about all newspapers in America, so that's our population. And if we do a sample, we would want to get a certain group of newspapers for which we have data, but we would want them to be representative. So we would want a mix of major newspapers, small newspapers, rural newspapers, just to have a good idea to be representative of what the population would look like. So they're asking us, is that sample representative? Just what I was talking about. And here's some different descriptions, and they're asking you to determine if you think that's a good representative sample or not. So daily newspapers in the 10 biggest cities in the United States, would that represent all newspapers in the United States? Not representative, maybe representative of the biggest ones, but you've also got the small town subs. Okay, so they only represent newspapers with large circulation, so you wouldn't be a good representative of everything. One newspaper randomly chosen from each of the 50 states. That would be a good representative as far as geographic regions would be represented. I would want more. I would want more than one newspaper from each of the 50. I would take 50 and maybe select 15 or 20 from each one of those states. All newspaper affiliated with a national media conglomerate, probably not representative. That you don't really know anything about that national media conglomerate. Is it political or not? Does it represent one political party? Does it represent one segment of the population? So we would need to know more information than that. So probably not representative. All newspapers in the country are listed alphabetically, and every 10th one is chosen. So if you go into statistics, this would be a systematic sampling, and this should be a representative. So we've got all the newspapers, and we're just randomly, well, not randomly, we're going to systematically go through, pick out every 10th one. Some of these may be big, some of these may be small, but that is usually recognized as a good representative. Okay. Here's some circulation numbers that we've seen so far. The circulation numbers that we've seen so far in terms of the author of this, they think that was population data. I have no reason to dispute it, but that would be, if it was population data, that would be all the newspapers, and that data should have come there. It's not 100% clear from the source. It appears that these numbers are an average of all print newspapers in America, so that's what it is advertising to be. Okay. The next table shows the results of a 2015 survey in which adults who read newspapers were asked, in what format do you read these newspapers? Here's print only, print desktop computer. So they've taken the total number of respondents, and the percentage that did print only, that was the 51%. So it is the part divided by the whole. I added up the total number of people who responded. 0.51 or 51%, 11%, 14%, 5, 7, 7, 5. And the question they're asking about this is, which would be most effective in illustrating this data, a scatter plot, pie chart, or bar graph? Well, a bar graph would be okay. A scatter plot, I wouldn't really think about a scatter plot. A pie chart would be a good idea. That's what they're responding with, the pie chart / bar graph. If all of these can only be done by one response, if this adds up to 100%, then a pie chart would be good. Elsewhere, if there's some things that there was some commonality, print, desktop, mobile device, or desktop, one of these could be some overlying data. We saw that in those Venn diagrams earlier. Then we couldn't do it. But it looks like all of these add up to 100%. Pie chart, 100% would go to 360 degrees, so it would be a good representative way and a quick way to see it. So I go along with the pie chart. How can you tell that this data came from a sample rather than a population? The population would be all adults in America who read newspapers, and it would be impractical to get responses from all of them. So I would pick samples just as a default method, unless we know that that was everyone that we were concerned with. It's a relatively common belief that print newspapers are becoming a thing of the past. Do you think the data above supports that idea? It doesn't seem like it. I mean, it's going down, but there's still people that are reading newspapers. I think that's still a good medium. You know, you pick up, grab it, read it. I think it's here for a little while. Okay, that's the end of that lesson. In fact, it's the end of Unit 1. So I recommend going back, reviewing the material, reviewing the lecture slides, reviewing the full blank slides or completed slides that I've added on the Blackboard. And I will see you next time.